Hi, welcome to this session about Microsoft Graph change notifications with resource data. I'm Vincent Biret. I work at Microsoft on the Microsoft Graph SDKs as a software developer, and I'm based out of Montreal, Canada. So today we're going to see together a few things about Microsoft Graph change notifications. First, we're going to have a little recap on what are change notifications, what are they useful for, and so on and so forth. And then we're going to deep dive on change notifications with resource data. After that, I'll deep dive into a demonstration, show you some code, show you how it works, and then it will be time to say goodbye and to reach to a conclusion. So if we first look at change notifications that have been existing in Microsoft Graph for a number of years now, why would you want to have change notifications in the first place? Well, there's a number of scenarios where whenever a change happens in Microsoft Graph in all the data that's sitting behind Microsoft Graph, that you want this change or whatever change happens to trigger some kind of logic in your application, right? It can be because you want to send a push notification to our user or an email or a text message. It can be pretty much anything, right? So you can support sending alerts or workflows or personal productivity or other scenarios of that type. It can be also because you want to analyze the data, right, and process it, but because you want to implement some kind of data loss prevention engine, or because you want to train some model and do predictions based on any kind of machine learning or artificial intelligence. Or it can be because you want to refresh the UI or refresh some cache data and so on and so forth, right? So there's a number of scenarios where you want to know when something has changed in Microsoft Graph so you can trigger something on your in your application. One pretty bad design pattern we've seen over the years and that you should not be doing is continuous pull. Basically, you have your end user using your application here on the left. On the right, you have Microsoft Graph talking to all the different services in Office 365. And whenever another user or another application performs an action like sending an email or updating some kind of file, doesn't matter, what happens to detect that changes that the application on the periodic schedule pulls the data and says, hey, Microsoft Graph, do you have anything new for me? Yes or no? And then either you get the answer, or after some time, you might get a response from Microsoft Graph, which is 429, too many requests. It's basically Microsoft Graph telling you, hey, your application is querying me too much. I cannot sustain that rate of queries. Please back off, right? And that's going to happen pretty soon as the application is used by a large number of users and or that it does a large number of queries. So you should avoid, whenever you can, continuously pulling Microsoft Graph. It's bad for your application stability and performance. It is also bad for Microsoft Graph as a service. So it's better for everyone if you avoid doing that in your application. What you should be doing instead, again, we have our user using our application on the left, we have Microsoft Graph on the right, and our application is going to create a subscription. So it's going to tell to Microsoft Graph, hey, for that object or for that set of objects, if anything changes, something gets created, something gets updated, something gets deleted, please let me know, right? And let me know at that URL. So whenever you create that subscription, you'll provide a publicly addressable HTTP endpoint where Microsoft Graph can call you back and say, hey, here is something that has changed. Go look it up, right? So once you've done that, whenever a user or an application makes a change in the data and performs an action, it will trigger a notification from Microsoft Graph. So Microsoft Graph will call your endpoint and say, hey, something has changed over there, and then it's up to your application to say either I don't care and discard it, or go and get the changed data and understand what has changed, right? And eventually on a periodic cycle, you need to renew those subscriptions as well. Because those subscriptions are of a time to leave, they either leave for a couple of hours to a couple of days. You need to continuously tell Microsoft Graph, hey, please keep my subscription active for the next couple of hours or for the next couple of days, right? And this is how it generally works. So you save a lot of round trips compared to the polling situation, where instead of polling continuously Microsoft Graph whether there are changes or not, you only query Microsoft Graph when we tell you there is a change, and that reduces the number of calls drastically, and that improves the performance of your application drastically as well, right? But still, at scale, having to get that data after receiving a notification can be problematic, right? It increases latency, something can go wrong, and you want to avoid that if possible. So back at Ignite 2020, we have released in general availability change notifications with resource data. So they basically work the same way as basic or plain notifications, if you want, change notifications. Again, you have your user on the left, you have your Microsoft Graph and these services on the right, and you create a subscription. But instead, this time, whenever you're going to create your subscription, you're going to use a certificate, and I will detail why. Whenever you create that subscription, you'll use the same APIs, the same mechanisms, but on top of that, you'll tell Microsoft Graph, hey, whenever there is a change, tell me there is a change, but also give me the data that has changed. So this way, I don't have to query Microsoft Graph back. Right, and in order to do so, not only you will flip a flag, but you also include a certificate public key. That is very important, not the private key. Once you do that, again, you will have endpoint validation, and once an action is performed by a user or an application on Microsoft Graph, well, it will send you a notification, but this time, this change notification contains data. Not only it tells you, hey, something has changed, but it also tells you, this is the data that has changed, and here's the data with you. But that data will be encrypted, and I will detail why and how you can decrypt it just in a few seconds. Again, you still need to renew subscriptions on a periodic basis. But you can see now, if you compare to the previous schema that I showed you, that you save the round trip, right? You don't have to query Microsoft back anymore, Microsoft Graph back anymore to get this change data. And at scale, that is going to save you a lot of latency and a lot of places where potentially something could go wrong, right? You have something which is more robust and has better performances at the end of the day using change notifications with resource data in comparison with plain or basic notifications. So why do we encrypt the change notifications to begin with when they have resource data? Well, again, your endpoint that you're providing to Microsoft Graph is publicly available on the web, right? And if we compare those change notifications with the basic ones, you get into a situation where we send you not only the notification, but the data that goes with it. And that data is enough for you, for your application to start doing some things, right? You take it for cash, and it will, your application will say, all right, I have that data that I need to analyze or do something with, right? So you need a mechanism to make sure that data actually comes from Microsoft Graph. It doesn't come from a third party, hasn't been replayed or played multiple times or sent to you multiple times, and also hasn't been tampered with in any form or shape, right? You don't want a situation where somebody crafts a payload that looks legit and sends it to you, and your application starts doing things without having to check anything. Before, it was not a problem again, because you had to call back Microsoft Graph to get the data. So you had to go through authentication and authorization, and you had to make sure that to get some data and make sure that something had actually changed before you could trigger any kind of sub-processing in your application. But because we removed that step, now we need another kind of mechanism to make sure that everything is in order, everything is secured, and you don't have any kind of malicious actor trying to make your application do things because they discovered the endpoint or something like that, right? So the first thing that's going to come with these change notifications with resource data are validation tokens. Those validation tokens are JWT or JSON Web Tokens, and they are the same kind of tokens that we use for authorization in Microsoft Graph. The same kind of bearer tokens that you send us to tell, hey, I'm this user or I'm that application and so on and so forth. Well, we send you back that kind of token so you can know that the call comes from Microsoft Graph, but also that it comes from Microsoft Graph and it's been sent recently, because those tokens also contain a not before and an expiration date, so they are only valid for a specific period of time, right? So again, those change notifications are going to come with those additional validation tokens, and what you're going to do is use any library you have in your ecosystem, whether it's .NET, JavaScript, Java, or any kind of other ecosystem. There's tons of libraries that help you to validate JWTs. And what you have to validate is the issuer. So where did it come from? And that's going to come from the Microsoft Identity Platform, right? And then you also need to validate the audience. Who is it? Who is that token valid for? And that's going to be your application. Your application that created the change notification subscription will be the audience of that token. You also have to make sure that the lifetime is still good, that it's not an old token that somebody grabbed somewhere and is trying to send you and replace some kind of payload based on that. And you also need to make sure that the signing keys are valid. Those signing keys also come from the Microsoft Identity Platform. So it's not a handcrafted token. It actually comes for real from the Microsoft Identity Platform, right? And you will, once you validated those different tokens, you know for a fact that it comes from Microsoft Graph and not from anybody else, basically, right? And it's really important to validate all the tokens. If they are valid, great, perfect. Keep going, and we'll see what you need to do after that. If they are invalid, though, just discard completely the change notification that you just received, and even try to investigate why you received that change notification with invalid tokens, right? It's important to make sure that somebody is not trying to tinker around with your application and your infrastructure. So then, the change notifications with resource data are going to come with a set of different fields. First, you're going to have a field that is going to be called data key. And that is because whenever we craft that change notification that contains the change data, we use the public key that you provided to us previously. We also generate a symmetric AES encryption key. And what we do is we encrypt the payload with that data key, and then we encrypt that key with your public key, so that you're the only person or the only application who is available to decrypt all of that, using your certificate's private key, one, to decrypt the data key, and then using that data key to symmetric key to decrypt the payload itself, right? So the first thing you're going to need to do is decrypt the symmetric key. So it's based in base 64 encoded by default, so you need to do that first, right? And you have tons of libraries to help you do that. And then again, if we come back to the certificate that you used at the very beginning to create the subscription, well, you will use a certificate private key this time, plus that base 64 decoded data key. And what you're going to do is an RSA decrypt using your private key on that data key, and you'll get this symmetric key that's ready to use to do other things after, and we'll detail that just in a few seconds, right? So again, data key, you base 64 decode it, then you take that, you take your certificate private key, and you do an RSA decrypt, and you'll get your symmetric key ready for use, right? So once you have that symmetric key, the first thing you need to do is validate the signature of the data. You want to make sure that that data actually comes from Microsoft Graph, that it hasn't been tampered with, and so on and so forth. And of course, you have TLS under the covers. That's always securing the transport layer and making sure that everything stays safe. But just in case, we added that extra layer of security to make sure that everything was originating from Microsoft Graph, and it's not a rogue player trying to actually make your application do things, right? So you will have a data field. you can take the data field and again base64 decode it. And then you can take the symmetric key that we just decrypted a few seconds ago with that base64 decoded value and do a hash comparison. So you'll take that value, take that symmetric key, and use that symmetric key to do a hash of that value. And you compare that information with the base64 decoded data signature field that is also attached. So once you compare those two things, if they match, you can proceed. If they don't match, just discard the change notification and investigate where it came from and why it's invalid and so on and so forth, right? And again, we do those things too, so you can make sure that it comes from Microsoft Graph. The data hasn't been tampered with or anything like that, right? So this is why it's really important to validate the signature and to discard any change notifications if they are not valid. Now, the last step, now that you know that everything comes from Microsoft Graph and you have a private key and so on and so forth, is to make sure, well, that you get the data and read it so you can use it. Again, you already have a data field, you already have a symmetric key from the previous step, and you're going to take that symmetric key and the data field to do an AES decryption. And this is where you'll get the value of a payload decrypted, available as JSON, and you can do whatever you want with that, right? So before I diving into the demonstration and I show you how those things work, today we have two supported resources available with change notifications with resource data. The first one is Teams, chat, or channel messages, and those were just made generally available back at Ignite 2020 a couple of weeks ago, and they are ready for prime time, and you can use those in production, right? We also have Teams presence, so am I available, am I online or not, and if not, what's the reason why I'm not online, and so on and so forth, all that kind of information. But it's also available as a public preview at the time I'm recording this session. So you can subscribe to those information and trigger some kind of logic based on people's availability. This is especially useful for call centers, for example, that want to start routing calls to specific agents based on their availability or other things like that, right? And again, if you want to request additional support for rich notifications or change notifications with resource data, you can always go to microsoftgraph.uservoice.com and say, hey, I want change notifications with resource data for Outlook emails or for Outlook events or for something else. And this way, the diverse product teams working on the different APIs will see that there is a demand, and they will start implementing that additional set of features for those resources on Microsoft Graph. All right, enough slides. Let's jump into the demonstration. So before I begin, you'll see I'm going to be showing you code and making sure that I explain things as well as I can. But should I not explain everything very well, or should I skip over a few things in the interest of time? All that code is on GitHub. It's available for you to clone and to play with and to experiment with. And all the setup is explained step by step on GitHub, right? The end of the session, I'll give you the links to all those different samples. Today we have samples for .NET, ASP.NET MVC Core. We have samples for Java Spring, and we also have samples for Node.js, I think Express, if I'm not mistaken, based applications, right? So you can use those samples either to start building on top of it, or you can just use it to explore it, right? So before this session, I went on and I created an application registration. I gave it the proper permissions that I need to have in order to create subscriptions. And then I got my tenant ID, I got my client ID, which is my application ID, and I got a client secret. The other things I've done, and it really depends on your infrastructure and how you want things to work, is I went on Azure and I created Key Vault. And that Key Vault has a self-sign certificate. So that's the certificate I'm going to be using to encrypt and decrypt the change notifications with resource data, right? What I've done also is I've granted the permission for my application to read into that key vault so it can access that certificate. And again, I'm skipping over that because all those step-by-steps are documented in the sample itself, and I don't think it's really interesting to see me clicking around. I think the code is a bit more interesting here. So that's for the first two parts of the configuration here. Now, here we have a few settings that are set up for the subscription itself. I am saying, hey, I want to subscribe to teams, specifically to that team with this specific ID. And then in the channels, I have that specific channel, which is the general channel. And under that, I'm subscribing to the messages, right? So this is how I tell Microsoft Graph, I want to subscribe to that specific resource on Microsoft Graph, right? Of course, I'm going to tell Microsoft Graph also, hey, please send me the resource data whenever something changes. And I'm going to be acquiring this specific scope, this specific permission in order to be doing that. Again, all those different permissions and what do you require in what case and so on and so forth. All of that is documented in our public documentation. So you'll be able to select the proper scope depending on what resource you're interested in at the end of the day, right? And the last thing I haven't talked about yet is this URL, right? Again, Microsoft Graph change notifications work with publicly addressable URLs. So it's really important that whenever you are debugging locally or whenever you are deploying a production service, you make sure that your URL is publicly available, doesn't require any kind of authentication or authorization, and all that works, right? Of course, I'm going to be debugging on my local machine, and that is not publicly available. I don't have any public URL pointing to my machine. So I'm going to be using a tool which is called ngrok. It's a simple command line tool that allows some kind of service to open and create a publicly addressable URL on the web, and then whenever any call will be coming to that service, it will tunnel back those calls to my local application. So for that, the first thing I'm going to need here is what port I'm going to be exposing. In that case, I'm going to be exposing this debugging port, which is 19742. And then I'm going to use that command line tool. So ngrok here. HTTP, because we're tunneling HTTP and HTTPS, 19742, if I'm not mistaken. Perfect. And the other thing you want to include and make sure you include here is this option, host -- host header equals rewrite. So what's that going to do is it's going to rewrite the host, that is usually something.ngrok.io, to localhost. So any request that comes on HTTPS and so on and so forth is actually valid, and the web server understands that it's actually for this application and not for something else, and it responds to the different HTTP request. That's why it's important. And again, all of that is documented in the GitHub sample. So after a few seconds, I should see ngrok telling me, hey, I started a tunnel for you, and here is the URL for that tunnel. There we go. So I'm going to be taking that information here, putting it back into my settings here, and I'm going to start debugging. So now that the application is almost started, we are going to switch back to my development tenant. And if we look at our sample, this is how it's going to welcome you. So that sample supports two modes. Either you can use delegated context, meaning that the application is represented a user and itself at the same time when it does any activity, or you can use an application-only context where it's only representing itself, no user in the context, right? That really depends on your scenario and what kind of application you're building and so on and so forth. There's tons of documentation about that, right? So if you want to use the delegated context, you can sign in here and then create the subscription. If you just want the application only, you can go ahead and create the subscription by clicking on that button here. And what's that going to do? I'm going to show you the code. It's going to reach out to Microsoft Graph, create the subscription, and we should be ready to go. So because it's a sample app, again, you can watch any notification that's coming back here. And now we just need to perform the action. So if we actually go to Microsoft Teams here and to the specific channel and post a message in a few seconds, we're going to be able to start posting messages that we should see appearing here anytime soon now. And there we go. So here you can see that I've received a few things. If I format that for you to see. There we go. I'm also going to make it a bit bigger. So we can see that we receive a change notification, we receive the payload, but we also at the same time validated the tokens, validated the signature, and decrypted the payload. That's all the things we did. And now the payload is that. And that is actually the representation of a chat message or a channel message, to be exact, on Microsoft Teams, right? It tells you who posted the message, it gives you my amazing text, and so on and so forth, right? So you get all that information. And then later on, you can do some processing or send a notification to users, whatever your applications needs to be doing. So if we dive in the code a little bit to show you how that's done. The first part is the subscription controller here, and I'm going to be just moving that out of the way as well here so we have more space. So the create subscription part is actually fairly simple. It just works like plain notifications used to work so far. The only differences here that you will see is you have the include resource data flag to tell Microsoft Graph, hey, I want those that data to come with the payload. And then we have the encryption certificate. So that's just the public key of the certificate. Don't send the private key. The private keys should always stay private and private to your service. This is how we maintain trust between the two services, right? And then you can give it an ID. That's something you can set yourself to say either the certificate ID, the thumbprint or something like that, or some other kind of ID that will help you locate the certificate back when we send you the change notification. So you can decrypt things and so on and so forth. So then once that is done, once that subscription is created, what you will be able to do is listen for change notifications. And how that is done is that you get here, you'll get the payload here that is available. And if that payload contains validation tokens, first you have to validate those and make sure they are valid. Here, that's what we're doing. So here we are using that custom service, and then you can move on for the decryption. So for the validation here, we use the Microsoft provided libraries from our friends at the Microsoft Identity Platform. And what this does is basically it relies on the well-known configuration and a few other things to say, all right, I want to be able to validate tokens. Here's where you get the configuration. Here's what you should be looking for and validating for me with my app ID, with a lifetime, the issuer, the audience, like I mentioned earlier. Just tell me whether the tokens are valid or not, right? And once you do that, this little service that I built here will do that for you. Just call it and give it a bunch of tokens, and it will tell you whether they are valid or not, basically. So once we've done that, we need to decrypt the change notification, but before that we need to validate the signature and so on and so forth. So here, if we look into that, it's fairly easy again. We have the encrypted payload, the encrypted symmetric key, the signature, and the certificate, the first three being passed from the change notification itself, the third one coming from my key vault. Use that then to, well, load the certificate in memory, and then I do some RSA decryption using the libraries provided by .NET to get the private key. And once I'm done with that, I can decrypt the payload. So whenever I decrypt the payload, I get the key here, do the decryption, what I was talking about. I compare the signature of what was given me by the change notification and what I found from my calculation and from decrypting the key and then computing the signature myself. And once I'm done with that, and once I know that works and that's actually a valid signature, I can actually use the AES decryptor to do the decryption here. So again, I take an AES decryptor, I can then load everything into memory and process the stream, and what I get as a result is finally a string, which is the JSON representation, which is what I was displaying on the earlier screen here, basically, right? Now, if we go back to the slide and conclude this session, so you can see that the first thing you should really be doing is avoiding continuously pulling Microsoft Graph. This is really bad for your application. This is really bad for Microsoft Graph. So avoid doing that whenever change notifications are available, right? And if they're not available, use the user voice to request for more support of change notifications. Then whenever they are available, we'll use them, change notifications. And if the change notifications with resource data are available, well, use that to obtain the resource instead of querying Microsoft back whenever you get a change notification. That's going to save latency for application. Your application is going to be more robust, and you're going to build better experiences for your users without compromising the performance. Before I leave you, I want to leave you with that QR code, or aka.ms/change notifications links, and that will point you to all the samples that I've used either in .NET, JavaScript, or Java, the public documentation, and a few other things to help you get started with change notifications with resource data, and the different samples. And with that, if you have any other thing you want to explore about Microsoft Graph, go to graph.microsoft.com. You'll find training, resources, samples, videos, and so on and so forth. So this is a great way to get started. Thank you very much for listening to my session, and have a wonderful European SharePoint conference.